Yes, friends, Bhuvnesh Oza back at your service with tutorial number 22. And in the series of protection of transmission lines using distance relays, we are on number 10. If I mistake not, there are 13 or 15 tutorials on distance protection, and we will end distance protection. We want to complete the complete power system protection. We have taken transmission line protection by overcurrent and earth fault relays. Then we have taken many practicals which can be done in laboratory and engineering institutes. And then now we are in distance protection. And we are discussing problems in distance measurement. Problems in distance measurement means distance relay is supposed to measure the impedance from relaying point to fault point, but it does not correctly measure and it finds many problems. So we are discussing one more problem in that. So that effect of faults on relays with unfaulted phases. What is this? YB fault occurs. So YB unit is going to measure the correct impedance and it is going to trip the breaker. True. But then RY fault is not resting. It is also measuring distance. PR, RG, YG, BG. To our fortune, because we are fortunate, the impedance measured by other units is more than the fault impedance. Therefore, there is no question of mal-operation. Therefore, this problem is not that very serious. But seriousness is what? That if the fault occurs very near to the relaying point, somewhere within 50% of the transmission line to be protected, then if YB fault occurs, RY will also operate and PR will also operate. And it will show that we have operated. So you are confused whether YB has occurred, RY has occurred, or PR has occurred. Similarly, it will be for RG, YG, BG. How it will measure the impedance? For that we have to do some mathematical treatment. Mathematical treatment I avoid because it is boring. The video will be too long. And the most important is I have to keep for me something. We are doing business. We want money. Therefore, I want that you buy module number 4 of power system protection of mobile app AdaptMe. Right? Pay money to me. Because right now I am teaching you free. But every now teaching free, how will I earn my bread? So, if you want to learn fully, you will have to buy the module. Anyway, going on further, what happens is this. That OP is the impedance measured by YB unit when YB fault occurs. Okay, well, correctly measured. But at that time, OQ is the impedance measured by RY unit. YB fault has occurred. And PR unit OS. Q and S both are out of the characteristic circle. So I am not worried. But if fault occurs at P dash, then all the 3 units will measure impedance. And all the three measured impedances are within the circle. And therefore, or anywhere below P dash also, near O. then you are under trouble. You are confused which kind of fault has occurred. This is the problem. It is not so that this problem cannot be solved. If I narrow down the characteristic circle, this was not possible with electromagnetic relays. Now with numerical relays, the quadrilateral characteristic has shown this problem will be minimal, mostly not. And you can reduce the width of the quadrilateral unit if you want to incorporate less fault resistance, then it will be yet easier, it will be better. So problem can be solved. But more serious problem is effect of delta Y transformer between relay and a fault. When there is a transformer present between relay and a fault, then the problem comes. You see, you can very well understand that this will never occur in zone 1 because in zone 1 there can never be a delta Y transformer. So zone 1 is not a problem. And in zone 2 and zone 3, if three-phase fault occurs, then also it's not a problem. It will be correctly measured. But the problem for more frequent faults, YB, BR, RY, RG, YG, BG, these faults, the impedance is shifted in angle. And when it is shifted in angle, the final impedance may go out of the characteristic. Relay will underreach. Relay will not operate when it is supposed to operate. This will occur in second and third zone. This will occur in second and third zone. So what occurs is something like this. Delta Y transformer, DY11. Pre-fault currents we consider 0, so IR 0. IY equal to I minus IB or IB equal to minus IY. Right. YB fault has occurred in secondary. YB fault has occurred in secondary. How it is measured in primary? Once again, you will have to do some mathematical treatment, which I will avoid here in this video. And to understand this figure also, you will have to understand the mathematics. That is also a trouble. But I'm sorry, you will have to take this for granted. What happens is, A is a source point. O is relay location. OA is source impedance. AF is the positive sequence impedance from source to fault. But OF, which we want to measure, is positive sequence impedance due to three-phase fault seen by the distance relay located in primary side of the transformer. See, YB fault has occurred in secondary. Sorry, three-phase fault has occurred in secondary. That three-phase fault is correctly seen in primary. But OF dash, if YB fault occurs in secondary, in primary it is seen as OF dash. So there is a 30-degree phase shift. And F dash may go out of characteristic circle and relay may not operate where it is supposed to operate in second zone. That means it will operate in third zone. And in third zone, if the fault is there, it will not operate. It is supposed to operate. OM dash is impedance seen by BR unit when YB fault has occurred in secondary. BR unit is in primary of transformer. ON is BR Y is RY fault. YB fault has occurred in secondary. RY unit is in primary. The impedance in is infinite. Impedance in is this is our biggest problem. As far as I know, this problem is taken up by somebody in research. People are doing research. Somebody has taken up the research, and this problem probably might have been completed also and might have been solved also. My apprehension is whether his philosophy has been taken up by any manufacturer? Does any manufacturer manufactures the relay based on this philosophy and solves this problem? If that is not done, then Bhuvanesh Oza is Dr. Bhuvanesh Oza. He is very happy because he is a doctor. He will get many congratulation messages, but useless, in vain, nothing. Philosophy has to be used by manufacturer, and manufacturer should manufacture a relay based on that philosophy. Problem has to be solved by manufacturing world. It has to be used in industrial world. Otherwise, philosophy of, I mean, becoming a doctor is very good. You will have 150 papers at your credit. When you will go to expert talk. You are being, uh, people are rather talking about you. Somebody will, somebody will tell about you that who is Mr. Such and such. So there are 150 papers at his credit, and he is a very learned professor. But that learned professor has nothing donated in industry. That nobody will tell, obviously. That nobody will tell. But I will tell that he has donated nothing in industry. And therefore, that PhD is useless, has no meaning. Anyway, I mean, this is my apprehension. I cannot remain without telling. But yes, this is a research problem, and somebody is trying, somebody is solving. I'm happy that somebody is solving. Problem is in second and third zone only, right? And that also for asymmetrical faults, not for symmetrical faults like RYB. With that, I end my talk because I keep my talk small, 30 minutes, 35 minutes, so that people are not bored. Those who are knowing protection, somebody are experts in protection, I can assure that they will learn 5% more at least 1% more if they hear this video. Those who are not knowing protection, they will not, they will learn the protection so good, they will be expert in protection, and they will put very good job, they will be placed very well. That much I am sure. So at the end of this, I like to speak one sentence. Races are meant to be run. Swami Chinmayananji says, you take part in races, running race, sport race, anything, any sport. Races are meant to be run. It's very good. You must take part. They are meant to be run, not necessarily to be won. जीतने के लिए नहीं है. It is not for winning. It is for taking pleasure of taking part in a race. It is for pleasure. It is for pleasure for taking part in sports. Very, very impressive statement, my dear friends. With that, I will remember my dear AdaptMe. AdaptMe is the business module of my sons. But I am father, therefore I am also having some part in that. And because I am putting up my modules on power system protection, I love my AdaptMe, and I would be very happy. I would request you all to share, to tell anybody. I would be very happy if somebody someday on social media or WhatsApp or on phone will tell me that, sir, do you know about AdaptMe? AdaptMe is a very good uh, application on mobile that teaches different subjects. Do you know? It is my baby, but he does not know, so he will tell me. That day will be a happiest day for me. So with that remark, I end my talk. Thank you, friends.